Hey guys, just NaCl Bay over here. Wait, you don't know what that is? Sorry, you might know me by my other name. Salt Bay. Oh, somebody's calling me. Got a blast! Hey guys, it's Aneesha. So sorry about Salt Bay back there. He thinks he's so cool by calling salt by its chemical name NaCl. Yep, that's right. Salt, the thing we put on all of our food to add flavor, is made up of two elements. Sodium, a soft metal, and chlorine, a poisonous gas. Now, how do these two elements that are so different and definitely not edible create something we consume every day? This substance is formed by something called an ionic bond, which is the transfer of electrons between atoms. Not only are sodium and chlorine different in their properties, they are also super different in their electronegativities. Electronegativity describes how much an atom can attract electrons. Looking at the periodic table, atoms become more electronegative as you go up and to the right, making fluorine the most electronegative element. When two atoms that have a high difference in electronegativity come together, the atom with the higher electronegativity attracts electrons more, and the electrons will transfer from the atom with lower electronegativity to the other. In table salt, the electrons transfer from the sodium to the chlorine atoms. Once this transfer happens, the atoms are bonded together and can form the salt we know and love. There is one other way for atoms to bond together to create substances that we can use. Take a look at this glass of water. Finally! We know that water is made up of hydrogen and oxygen, but those are two gases. I'm drinking gas? No. But how do they come together to create the liquid that we need to survive? Well, the second type of bond between atoms is called a covalent bond. Here, the atoms don't have too big of a difference in electronegativity, so they can share the electrons between themselves. But why do atoms even need to bond in the first place? Well, the electrons in the highest energy level of an atom are called the valence electrons. They're super important because they're the ones that actually participate in bonds, being shared or transferred between atoms. Different energy levels have a different maximum number of the electrons that can occupy it, but the important thing to know is that all atoms really want their highest energy level, or their valence shell, to be completely filled so that they can be stable. Because of this, atoms will try to gain and lose electrons by bonding with other atoms. Elements that are closer to being completely filled are more reactive. For example, chlorine with 7 valence electrons only needs one more electron to have a complete valence shell, so it's highly reactive. Sodium with 1 valence electron is highly reactive because it really wants to get rid of that electron. Therefore, sodium will give its extra electron to chlorine so that they can both be happy. One really important element is carbon. Without it, life literally wouldn't exist. One of the main reasons why carbon is so unique is that it has 4 valence electrons, meaning it can create up to 4 covalent bonds with other atoms. It can create single, double, triple bonds, and even then, a bunch of different shapes like straight chains, branch chains, and even rings. Carbon can even bond with itself to create super strong substances like the diamonds in our jewelry or the graphite in our pencils. Some of the molecules needed for life are over 1 million atoms long. So carbon's the reason why all living things exist, because we require these super complex organic compounds that only it can make. Elements like carbon are able to bond with each other, creating the living and non-living things all around us. Thanks for watching this video, and I hope you learned something new.